Hello everyone. Today we cover even and odd function, and my only real life student is visiting my class, maybe not for a long time, and it does not look like he is going to listen to me actually. Looks like he's gonna sleep. Well, while he's with us, maybe we can enjoy his view. Okay guys, we are going to start with definitions. So, definition, oh sorry, my screen is kind of shifting and running. Give me a second. So, definition. Function f of x. I don't like this thickness. Okay. It happens because I made it screen the grid too big. F of x is called even if f of negative x equals f of x. So you change the sign of argument, nothing changes. F of x is odd if f of negative x equals negative f of x. So you change the sign and the function changes the sign to change the sign, the argument. So pictures of even and odd functions. So I'm going to start with even function. So how even function is going to look? Oh, sorry, not very straight. Can make it better. Well, typical even function can look like this. I'm using absolute value, but can be anything else. As you understand from the definition, even functions are supposed to be symmetrical about y-axis because you kind of change the sign of your point. For example, point over here is x. I guess my student is leaving me. Yeah, he doesn't want to actually listen to my lecture. Okay, guys, I'm going to turn him off. That's just very distracting me that he doesn't want to watch me. So you have x on the left side, like negative x, and the value of f of x supposed to be same, and this is f of x, right? So I'm going to write down that the function over here is even. For odd function, the symmetry is about origin. So over here, y over here. Well, I'm not super creative. I'm just going to use the x function, right? A straight line. And it's odd function, something like this, right? The symmetry is about origin. So if you have x over here, so the value is f of x. And if you have negative x over here, the value is negative f of x. Well, this is minus, right? This is just a dashed line. What are important properties of even and odd functions? Well, from the point of view of Fourier transforms and integrals. Important properties. Well, because in our coefficients, we calculate integrals. I'm going to write down the typical integral from negative L to L, f of x dx. Let's see what is going to happen if the function is even. Let me change the color, for example, to green. And for example, my L is over here, my negative L is over here, my L is over here. So we remember that integral is area under the curve, right? So we calculate kind of this area and we calculate this area, and we do see that these two areas are identical. So for us, it's going to mean that we can limit ourselves to calculating only half of the area from 0 to L of the same function and double the result. How it's better? Well, guys, 0 as a limit is always good, right? Remember, you substitute 0 in most of the functions and they are zeros. Otherwise, nothing better. And you can always use the full integral. So I'm going to write down if f of x is even. So that's going to be our first property. I don't want to move too far away. Now, guys, let's deal with odd function and do the very same integral for odd function, f of x dx. So what do we have for odd function? Let me use a different color. So for odd function, it's again area. Well, I'm going to just maybe put L over here. Consider L like equals to x. Let's do L here, negative L, and L here. So the area is equal, right? Because the function is symmetrical, but the sign of the area here is positive, and the sign of the area here is negative, which means that when we add them together, we are going to have exactly 0. And maybe kind of how are we going to use these properties? Well, let me kind of finish the equation that integral is equal to 0 and write it down if f of x is odd. Well, you know, when integral is equal to 0, it's always nice, right? You don't need to integrate it. Well, now we are going to talk a little bit about more complicated functions. So, products of two functions, f of x and g of x, how the integrals are going to behave if you do have products. Well, first, let's consider what happens to a product if you mix up even and odd functions, or like just have two even functions. I'm going to start number one. Let's consider that function f is even and function g is even. What is going to happen to the product? Well, in the product, if we change the sign in front of the argument, because both functions are even, they're going to just kind of forget about this and give you original function. So you see the result is going to be even too. Second case, is if f is even and g is odd. Let's see what is going to happen. F of negative x multiplied by g of negative x. Well, because f is even, it's going to just kind of drop the sign. G is odd, so it's going to be negative g of x. And the result is going to be minus f multiplied by g. We see that the result is actually going to be odd, right? Because you change the sign of the argument and the result is going to be odd. Maybe I should write down the whole function, otherwise it's not very clear why it looks like this, g of x. And I'm going to write down odd, right, because of this minus. Well, what is going to happen if we have f odd and g even? Well, you can understand that we are going to basically have same situation. Just a minus is going to come not from g, but from f. But the result is going to be same. And the last case, when both functions are odd. Number 3, f odd and g odd. What is going to happen? Well, let's calculate what is going to happen to the function. Sorry, I pushed highlighter instead of my black marker. F of negative x multiplied by g of negative x, because both are odd, they're going to produce minus in front, right? When we change the sign of the argument. And this minus are going to combine together and give us a plus. So basically the function is not going to change and the result is going to be even. Well, what does it mean? If the functions are like both even or both odd, we are going to have even result. if the functions are mixed, either even odd or odd even, we're going to have odd result. Well, maybe it's not a good way to kind of, write it down. Actually, I don't know how to summarize it to not mix it up. So we're just going to remember even or odd, the result is even. And if they are mixed, the result is odd. How it's going to help us? Well, remember that we are dealing with lots of integrals of some function by cosine or some function of sine. We remember that cosine is even and sine is odd, right? And we also can have a function which we multiply by sine and cosine even or odd. So, you know that cat is actually kind of not allowing me to see what I'm writing down. So back to Fourier series. Back to Fourier series. AM equals coefficient from negative L to L f of x cosine of m pi x over L. A standard kind of the formula for coefficient AM, right? We do know that cosine is even function. I think I'm going to turn off my cat because the picture is blinking. I don't like it. And maybe I should just kind of make a little stop and move to a different place. Sorry, let me stretch it again. So what we have over here, I'm sorry, started writing down even. Let's consider the case that f of x is odd. I'm going to write down if f of x is odd, we have odd function multiplied by even. The result is going to be odd. We remember the integral of odd function then is going to be equal to 0, just because we proved that odd function is going to give us 0 integral. So that's going to be, I'm going to label it at case A. Case B, let me go back. If f of x is even, then we are going to have what? Two even function multiplied. Even, and we know that it's going to be even. And for even, we are going to have integral be equal to integrals, well, I'm going to put from negative L to L, from 0 to L, f of x cosine of m pi x over L dx. I don't know, I probably should write down the integral over here, the integral of negative L to L, and label that. This is case A and this is case B, okay? Maybe a little bit more like clear. So what does it mean, guys, for us? The coefficients of the series are going to be, remember that if the function is odd, right, we are going to have integral of 0. What does it mean? That all coefficients am are going to be 0. And in this case, the series is going to be Fourier series will have only sine terms. Well, again, we usually calculate Fourier series by calculating coefficients am and bm. So, well, because the function is odd, all am terms, because it's going to be all odd multiplied by even odd, are going to be equal to 0. So we are going to have all coefficients am equals to 0, which are coefficients of cosines, right? Because am multiplied by cosine, which means that we are going to have only sine series. Well, what is going to happen if the function is, sorry, no, sorry, not supposed to be here. Give me a second, guys. I shifted something. Let's consider what is going to happen if the function is even or odd for the sine coefficients. Maybe I should write summary for cosine coefficients first and then kind of finish this. Give me a second, guys. Okay. So let's finish this case. So if function is odd, my Fourier series is going to look like this, just like a final statement over here. It's going to be something like Bm sine of pi mx over L, and m goes from 1 to infinity. So odd function, mnemonic rule. Odd terms. By saying odd, I mean sine. Sine is odd function, okay? That's going to be like a conclusion. For even function, we are going to have the cosine terms. Now, let's consider coefficients Bm now. Bm are going to be minus L f of x sine of m pi x over L dx. Sine is odd function, right? So what is going to happen? Sine is odd function, so if f of x is odd 2, we are going to have odd multiplied by odd, and that was case number 3. Odd multiplied by odd is even, right? Even. For integral, for even function, we can say that integral from negative L to L is going to be, well, I'm going to copy f of x sine of m pi x over L dx can be calculated for even function as 2 integrals from 0 to L f of x sine of m pi x over L dx. Yeah. So if the function is odd, the integral can be calculated like double integral. What is going to happen if the function is even? Let me move over here. If f of x is even, we have even multiplied by odd, which is going to produce odd, right? Which is going to mean that integral of negative L to L f of x sine of m pi x over L dx is going to be equal to 0, right? For odd functions, integrals are 0 because areas are equal but opposite sign. Which means that if f of x is even, then we will have only, well, the sine terms are going to like be all equal to 0. We will have only cosine terms. Well, cosine terms are what? F of x is going to be equal a0 over 2 plus am cosine of pi mx over L. M from 1 to infinity. I'm going to scroll it a little bit. Well, which is very good, right? let me just go back now, guys. I want to show the whole thing at the same time so you can see what is going to happen to the function and the whole thing. Let me use a different color. I need this. So I'm going to start, I'm going to go back over here and kind of look at this one. So if the function f of x is odd, we know that all terms f of x are going to, like all terms am are going to be equal to 0. Odd function is producing 0 terms, and the series is going to be only the sine series. Now, what is going to be the sine series if it's odd? Let me go over here and find, okay, if f of x is odd, then the terms, the coefficients bm, let me label it over here, then bm will be equal to the double function. So I'm going to kind of circle this one because it's odd, right? The f of it is odd, and write down that the coefficient bm is going to be equal to this integral. So for odd functions, they're going to be only sine terms, and you can calculate the coefficient by integrating only half of your period. And now let me change the color to, for example, green. Now, what is going to, now I'm going to move over here, and for even function, if f of x is even, we know that all sine terms are going to be equal to 0, and we have only cosine series, right? But what is going to happen to cosine series if f of x is even? If f of x is even, the cosine terms are going to produce coefficients equal to double of the whole period. I'm sorry that this thing is making like, I'll try to go back. Okay, to double. So I'm going to make an arrow over here. So the coefficients can be calculated as over the half of the period, and just kind of you multiply it by 2. Yeah, well, I'm hoping that kind of this is clear. Maybe I should summarize it as one, like, or two formulas. It's going to be a little bit easier. Okay, maybe I should keep something like different color. Summary from all these even and odd things. So if f of x is odd, then the series for f of x is not going to have any even terms, which are like cosine terms, right? And that's going to look like this. bm, sine of pi m x over L, m goes from 1 to infinity, and bm can be calculated as 2 over L integral from 0 to L f of x sine of pi mx over L dx. So we can calculate it over just a half of the period and multiply it by 2. I think I'm missing L somewhere in my previous coefficients. Sorry. Over here it's supposed to be 1 over L, and I don't know. I just kind of forgot to write it down, and where it's supposed to go again. I'm searching like where I'm missing 2. Yeah, because I started with integral and then I called it like bm. So I was not planning actually to do the coefficient. I was just planning to do the product, and then I moved to coefficient and forgot to divide by L. If you see that I forgot to divide by L, maybe I should divide by L over here too, just to make it like the full coefficient. And did I divide by, yeah, and over here too. Sorry, sometimes I start with having one thing in mind and then finish with another one. I guess I did not miss any L in denominator, but if you see it somewhere, okay, put it back, right? So I wanted to talk about the products initially, but then moved to actual coefficients, and the actual coefficient is supposed to have L in denominator, right? Remember the definition. Okay, so For odd functions, we are going to have only sine series, and the coefficients are going to be defined like this. Now, if, sorry, if f of x is even, it's going to have only even terms, and f of x is going to be a0 over 2 plus sigma am cosine pi mx over L. L looks like 2 actually. L, m equals 1 to infinity, and am is calculated as 2 over L, integral from 0 to L, f of x, cosine of pi mx over L, dx, of course. Sorry. Yeah, so if the function is purely even, we can have only cosine series for this. It's not like we don't want to calculate sine series. Just if you decide to calculate sine series, you are going to have just 0 coefficients. And so don't waste your time and don't calculate them, and just kind of know that they're not going to exist. Okay, well, it's making our life a little bit easier if you kind of deal with specifically odd function or even function. Of course, if the function is neither odd or even, you have to calculate all the coefficients, an and bn, no exceptions. The formula for a0 is not going to change, so I'm not going to kind of write down a different formula. Just for even function, you can calculate again, it's over the half of the period and then multiply by 2. Otherwise, like nothing else. Okay, I'm going to consider example of like very simple example of odd function. So my first example, example 1, I'm going to consider f of x equals x. And my function period is from -2 to 2, sorry, I wanted to write down 2, -2. And I'm going to write down that f of x plus 4 equals f of x. So my period t equals 4. The function is defined from -2 to 2, and it's periodic with period 4. So basically, I'm giving you a little piece of just normal straight line, and I cut it off, and maybe I should draw the picture how the function is going to look. So, well, let's imagine that this is 2, this is -2. So I'm going to have something like this, and the hole over here, and the black dot over here. So that's going to be my function on one period, and that's one period. I'm going to label it. That's one period. And then on next period, we're going to have same situation. And so on, okay? And x and y is going to repeat periodically, looking like this. See, so let's calculate the coefficients. So we do know that x is odd, right? What does it mean for us? We need only sine coefficients. Well, again, because it's odd, we'll need only sine coefficients. Well, let's do them. It's going to make our life half easier, right? Instead of two sets of coefficients, we calculate just one set of coefficients. I'm thinking if I want to set everything correct, okay, let me start. So sine coefficients are going to be what? 2 over L. What is my L? Guys, we remember that the period is 2L. So in this case, L is going to be 2 units, right? And we have 2 over L, which is going to be 2 over 2. And the integral from 0 to 2 x sine of pi mx over 2 dx. That's what my formula tells. Just calculate using the formula. Yeah, unfortunately, all these integrals will need to be calculated by parts, and that's what I'm going to do. I will calculate it by parts. So 2 over 2 is going to give me just 1, right? So I'm going to kind of miss it. And I'm going to have x sine of pi mx over 2. Why it's 2 here? It's supposed to be L, but my L is 2, right? And I'm supposed to divide this, because if I differentiate, if I kind of, why did I write a sine actually? It's supposed to be cosine, because I'm doing by parts, right? The integral of sine is going to be cosine of pi mx over 2. If you differentiate cosine, you are going to get negative sign, so we're supposed to put minus here. And we also supposed to divide by pi m over 2 this. Well, I'm going to put minus together with pi m over 2, okay? Pi m over 2. And minus according to the formula. And then we need to differentiate x, which is going to give us 1, and then just copy cosine. Cosine of pi mx over 2 divided on negative pi m over 2 dx. Well, I'm going to push it up. Well, again, mostly coefficients are not difficult to calculate. It's just a very boring procedure. So I'm going to kind of modify a little bit the first term. I'm going to write it down minus 2 over pi m x cosine of pi m x over 2. I forgot to place limits here and the limits here, okay? Limits 0 and 2. Minus and minus are going to give me plus, right? And that's going to give me 2 over pi m if I put it in front. And then I'll need to integrate cosine. An integral of cosine is going to give me sine of pi m x over 2 divided over pi m over 2, the coefficient of x. So maybe I should just take this one and kind of place this one squared and erase this to not copy everything one more time. It's just going to be the same coefficient, right? No minuses. Well, basically, we just need to do substitution of 0 and 2. You see how 0 is good over here because you substitute 0 instead of x, and it's going to give you just a whole term into 0. Okay. I'm going to substitute everything and formally like use the 2 and so the first substitution of 2 over here and over here is going to give me minus 2 over pi m multiplied by 2 cosine of pi m multiplied by 2 over 2. Substitution of 2 into sine is going to give me, sorry, supposed to copy the coefficient first, 2 over pi m squared. Yes, I'm going to just shift it a little bit this way. Sine of pi m multiplied by 2 over 2. So I just substituted 2. Now minus, and I substitute 0. Minus, and I substitute 0. So 0 over here is going to turn the whole term into 0 because x is 0. Yeah, cosine is not going to be 0, but because x is 0, it disappears. Sine is going to be 0 when you substitute x equals 0, just because, again, that's kind of sine of 0 is 0, so it's minus 0. You see that makes sense, actually, to kind of do half of the period, right? Because substitution of 0 is very easy. Well, basically, I already almost done. I just need to simplify my expressions. Well, I'm going to multiply this 2 and 2 and get 4 over pi m. Don't forget about minus. Cosine, and here cancel 2 is pi m, and over here minus I guess 4 squaring 2 and pi square m square, and the sine of pi m. Well, I want to say that the sine of pi m is going to be equal to 0. Well, what is pi m? Let me just draw a little picture. Pi m is like over first here it's pi, and then 2 pi, 2 pi, and so on. And that's going to be equal to 0 because sine is 0 at this point. So I'm going to write down that as 0. So this term is not 0. And actually it's going to alternate the sign, right? Let me kind of do the explanation for cosine. Scroll a little bit up. Cosine of pi m. Well, we are going to start with m equals 1, and that's first value is over here is negative 1. And then we move over here, and that's 1. And then forth and back, it's going to be alternating between negative 1 and 1, right? Maybe I should write it down that cosine of pi m is going to be equal to -1, m equals 1, 1, m equals 2, -1, m equals 3, and so on. We probably can unify this into -1 to the power of m. How about this? If it's 1, it's negative. If it's 2, it's positive. And for all odd powers, it's going to be negative, and even powers are going to be positive. Well, very good. We just plug it in back into the function and get coefficient bm, well, -4 over pi m by -1 to the power of m. I'm going to bring this minus together with m and have 4 over pi m -1 to the power of m plus 1. Well, now I'm ready to plug it into the series. And I remember that I'm not going to have cosine terms in the series because the function is odd. So my f of x Fourier series representation is going to look like this. It's like sigma -1 to the power of m plus 1, and then 4 over pi m, and then sine of pi m x over L, and here m goes from 1 to infinity. You see? So if the function was not even a rod, you will need to calculate like both am and bm, but we going to not calculate am because they are going to be zeros. F of x is odd. Okay. So what else? I'm going to consider one more example. Example 2. Well, just to show like maybe what is going to happen if it's opposite. Okay, so I'm going to consider very same function, f of x equals x, but I'm going to consider only the part of the function from 0 to 1, not from 0 to 2, and the period is going to be equal to, okay? So let me draw the picture of the function over here. Come on, I'm so bad in drawing straight lines. So I have 0 to x equals to 1. Well, maybe like this, right? And over here, a whole. And then the period of the whole function is equal to 2, which means that I'll need to kind of continue it over here. Okay. So what I did, guys, I took my function f of x on this interval and I extended it odd way. Well, I can extend it even way, just reflected about y-axis, right? I extended it odd way. So I made the full period and made the function odd, keeping the part which is given me over here. So function is going to look like this. Did not write down 1 here. Maybe I should not write down this one. And that's 1 here, y here, and x here. And of course, I'm going to, because it's extended all the way, I'll have sine series. Let me just calculate the coefficients, right? So I'm going to use my new formulas again. So I'm going to calculate bm again. Why did I calculate both functions odd? Well, there is no explanation, but just for change, I should consider one even function, right? Well, I don't know. Let's do this odd function first. I already started doing it. So bm coefficient is going to be what? 2. What is my L? Well, my whole period is equal to and equals to L, from where L equals 1. usually it's going to be given on L. So this interval is interval of L. Integral from 0 to 1, and we have x sine of pi mx over 1 dx, and again integration by parts, just 2 in front, right, minus x cosine, we already did this integral, so cosine of pi mx divided over pi m, plus integral differentiation of x is 1, right? And the cosine is going to be here, cosine of pi mx over pi m dx from 0 to 1 is going to give us 2 here. Well, the almost everything is same in this integral as in the integral before, just like different limits. And over here, we are going to have sine of pi mx divided over pi m squared, right? Substitution of the 0 and 1. Okay, well, let's do first 1, right? So we have 2 square brackets. Substitution of 1 here is going to give me cosine of pi m and over pi m plus sine of pi m over pi m squared minus, guys, I'm missing a minus here. I was writing it down, and then forgot about it. Minus, which is going to become plus if you substitute the 1, right? And because x is equal to 0, the lower limit, I'm going to have 0. And minus, and because sine of 0 is equal to 0, I'm going to have another 0, like in the previous case. So basically, I'm going to have 2 negative cosine of pi m over pi m plus sine of pi m over pi m squared. Well, again, guys, we remember that sine of pi m is like points here and here, right? Going to be 0. So this one is 0. And cosine of pi m is going to give us minus 1 to the power of m alternation, right? Let me draw the picture. That's going to be like minus 1, 1, minus 1, 1. So kind of. Okay, so I'm going to summarize it as 2, maybe minus this minus in front, right? And 1 over pi m, and that's minus to the power of m. And if I take this minus together, it's minus 1 to the power of m plus 1 over pi m multiplied by 2. So my final result is going to look like f of x equals minus 1 to the power of m plus 1, 2 over pi m sine of pi mx, and m goes from 1 to infinity. Well, you see, easy formulas to use. What is interesting, guys, a last remark over here. If you have only half of the period given, you can always extend the function in even way or in odd way and calculate either sine or cosine series. Usually the problems in the book are going to sound like this: extend the function even way and find a cosine series, or extend the function odd way and find sine series. Well, it's a bit like nicer, right, to have just like one set of trig functions. Okay, that's all for today. And I'm going to say goodbye and see you next time.